Well, that's better. Right, so we're outside here with the sun shining beautifully today. It's been the first day since our big storm. The visible light that comes from the sun being dispersed into or refracted, I should say, into a pattern that allows us to see the sky as blue. And what we want to begin to think about, talk about in the next days is the electromagnetic spectrum. And the electromagnetic spectrum is what allows us to do what we're doing right now, which is walk, talk, and make a little video. And the electromagnetic spectrum is what we have used in order to understand the origin of our universe, the size of our universe, our place in the universe. And for us, the most easy and obvious, I should say, the obvious manifestation of the electromagnetic spectrum is the sun, shining here over my head on this beautiful day of February 4th, 2021, in New York City. So it all starts with the sun, which is our main source of electromagnetic energy, the source in our neighborhood, in our solar system galaxy. And electromagnetic energy is created in the sun through a simple process that was determined or discovered once we understood the way in which atoms were constructed and the way in which they behaved when in proximity to each other. And the process that we now assume is driving the sun, we now understand is driving the sun, is the process of fusion. And fusion is an atomic reaction within the sun in which two hydrogen atoms are fused together to make a second new element, helium, and in so doing, producing energy, which is released from the sun in the form of electromagnetic energy. The most visible manifestation of the electromagnetic energy from the sun is visible light. Visible light is one of the types of electromagnetic energy defined by its wavelength and the frequency with which those waves travel from the sun through space. Visible light, as we may know, consists of violet, blue, or indigo, it's often said, green, orange, yellow, and red colors, which together make up white light, that light we see shining from the sun. White light is a combination of colors. Newton, the great scientist, Isaac Newton, was one of the first to understand how white light from the sun could be broken up into its colors by using a prism. And in fact, we may even see some effect of that in this lens as some light is distorted near my chin, being broken up. And again, the atmosphere and the molecules in the atmosphere of oxygen and nitrogen, primarily, they, refract some of the visible light and cause, again, the sky to appear blue. And if we look at the snow, which has fallen so beautifully here, we see how sunlight bounces off the snow, reflecting white light. And all the colors we see in nature are visible light interacting with some material. For instance, in my orange coat, a molecule which reflects light back to your eye as orange. So all the colors we see are really just light that is being reflected off of the material that you're looking at in the particular wavelength that you end up seeing. Visible light, therefore, is critical for us to perceive and understand the world around us. Our eyes are sensitive to electromagnetic energy in what we call the visible spectrum. The electromagnetic spectrum is the entire range of waves of energy that are produced by the sun's fusion and travel through space. Our eyes, again, sensitive to visible waves of light in the colors that I mentioned, but red primarily without the aid of some kind of device to split the visible light up as white light, until the light strikes the surface of something that has a molecule in it that either absorbs colors you do not see or reflects the colors you do. Now, what are the other forms of electromagnetic energy? Because the wavelengths of visible light are essentially benign to us. They do not cause any particular problem for us, whereas some electromagnetic energy is quite dangerous. And that depends upon the wavelength of the electromagnetic energy traveling from the sun through space. The shortest waves are your gamma waves. They are so short and arrive with such a high frequency that they can damage the cells in your body and thus cause you to be severely ill or even die. Gamma radiation is associated with atomic weapons and radioactivity. The first radioactive energy that was really understood as something unique in terms of electromagnetic energy were X-rays. So named because they were not really understood to be anything. They were unknown, the same way that X is an unknown in an algebraic equation. So X-rays got their name. And they too are produced by radioactivity, the element giving off high energy waves, which can be damaging to the human body. Gamma the shortest, then the next shortest X, and then slightly longer waves, I should say, would be your ultraviolet. Ultraviolet meaning beyond violet in the visible spectrum. Ultraviolet, which, as we know, can cause blindness when we look at the sun directly, because the sun is again releasing ultraviolet radiation. Ultraviolet, which can cause sunburn and skin cancer. Ultraviolet, which we try to avoid. Some organisms can see in the ultraviolet, but humans cannot. So our shortest wavelengths, gamma, our next slightly longer X-rays, then our microwave, and then we come to our visible light, which is only a small range of wavelengths. It doesn't encompass a lot of the electromagnetic spectrum. Again, the electromagnetic spectrum, a range of wavelengths from the shortest to the longest, from gamma to X-ray to ultraviolet to visible, to visible, and then slightly longer than visible, we have infrared. Infrared, which is also known as heat. So that when our visible light strikes the surface of a material and excites the atoms in that material, those atoms, the kinetic energy of those atoms, can generate infrared waves, which we read when we feel it as heat. Those are slightly longer. From infrared, we go to microwaves. Longer again still. And from microwaves, which we associate with that tool of the kitchen, and which is used in some forms of communication. Finally, our longest waves, radio waves, which can be a length, an individual wave. Imagine this, an individual wave traveling, say, the length of a football field. Or if we were to look from here and pan over to, say, here, that would be, say, the length of one radio wave. And radio waves, which we now depend upon to use as communication devices, sending digital packets of information through the air in our atmosphere, through space, from satellite to Earth, from satellite to satellite, from satellite to rocket ship. Those are our electromagnetic waves, from the shortest, gamma, to the longest, radio.